Hi guys, welcome to this page of the notes, and we're going to talk about a couple of things I'm pretty sure most of you are already aware of. I know that this is probably your first time taking geometry, but this wouldn't be the first time you would have heard this. You would have seen it in other math classes, probably even in, like if you took a physical science class or something like that in middle school, talking about complementary and supplementary angles. So let's just quickly refresh your memory on them. Remember the way it works. Complementary angles are going to be two angles that sum. When you add these angles together, they sum to 90 degrees. So really important, we'll go ahead and highlight that for you. Complementary angles sum to 90 degrees. I'll even write that right over here a little bit bigger so you can see it. Sum to 90 degrees, right? Sum to 90 degrees. You add them together, you get 90 degrees. And I give you an example. If you take an angle of 50 degrees, and you add it to an angle of 40 degrees, 50 plus 40 is 90. Those two angles, if you put them together, would sum to 90 degrees, a right angle. Then we have supplementary, which again, I'm sure most of you are familiar with, but just to be complete, for the sake of completeness here in our notes, supplementary angles are angles with a measure that sum, add together, to 180 degrees. 180 degrees. So sum to 180 degrees. Let me write that for you. These are going to sum to 180 degrees. And I have an example for you of those here as well. If you have an angle of 100 degrees and another angle of 80 degrees, if we were to add those two angles together, I would get 180 degrees. Please also note that these two angles, right, are going to form a linear pair. So this is a really important note, which I'll put in red. Supplementary angles form a linear pair. Now, we saw this idea of using a linear pair in a previous example problem. You can bet it's gonna show up again, right? When you have supplementary angles, yes, they sum to 180 degrees, but that's because they're two angles that form a linear pair. So this supplementary angles thing is really an extension of this linear pair theorem, and we'll use it to solve problems. So, now that we've covered that, let's just go ahead and jump right into a couple of example problems. Let's take a look at what we've got here. What I want you to do is use the diagrams I've given you here to find the missing angle measures, and please justify your reasoning. Why can you do what it is that we're going to do to find all of these angles? So here we go. Let's jump into this and see what we get. Okay, so what I'm told is that, look at this. Yeah, here's what we've got. I'm told that angle BFC is 50 degrees. So angle BFC is equal to 50 degrees. That's given. I'm also told that angle CFD is equal to 90 degrees. That was also given, right? This one, CFD, is 90 degrees. That's what that little square there in the corner means. It's a right angle or 90 degrees. So both of those were given to me. So those are angles I don't have to find. I was already given those. We need to go ahead and find the rest of them. I need to find DFE. I need to find EFA. And I need to find the angle AFB. So here we go, let's just jump right into this. Here's what I recognize right away. What I recognize right away is right here, let me go ahead and do it in red. That is a straight line. Boom, straight line. So what that means then is that this angle, BFC, plus CFD, plus DFE, those three angles form a straight line, right? A linear line, right? They have to sum to 180 degrees. So we'll use the angle addition postulate. I can add together the smaller angles to get the larger angle. So here we go. My first step is going to be to take angle BFC. I'm going to add that to angle CFD. So CFD. I'm going to add to that DFE. And here's what I know. I know that those three angles, because they form a straight line, have to sum to 180 degrees, right? 180 degrees. Well, look, I already know what BFC is. BFC is 50. I already know what CFD is. CFD is 90. So we plug that stuff in. I have 50 degrees plus 90 degrees plus, I don't know, DFE is equal to 180. No problem. Let's see here. 50 and 90 should get me what, 140? Yeah, 140 degrees. Equal to 180. Oh, that got weird. Awesome. Keep going. Subtract the 140 to the other side and I get angle DFE is equal to 180 minus 140. Yeah, that's easy. It's 40 degrees. Boom. Now, how did I do that? Again, that is the angle addition postulate. You should remember that angle addition postulate. We learned that back in a previous chapter and section. If I sum together those smaller angles, they'll all sum together to get me the degree, the angle of the larger, or to give me the sum of the larger angle, right? Add them together. So anyway, there's DFE. Now, check this out. Look at this. I have right now, what are those, right? DFE and angle AFB are what angles? Yeah, from the previous page of the notes, they're vertical angles. I know that these two guys right here, that one and that one, have to be congruent because of intersecting lines, the vertical angle theorem. They must be congruent. So, angle DFE, which I now know, is congruent to angle AFB. Right? Why? The vertical angle theorem. So vertical, sorry, I'm writing over my other one. I'll erase it before we get there. Vertical angle theorem. Now, what does that mean? Well, that means then that, do a substitution, angle AFB has to be equal to 40 degrees. Right? If these two angles are congruent and DFE is 40 degrees, that means AFB also is 40 degrees. Vertical angle theorem. This is fantastic. We're doing really well. There's only one angle left to find. I need to find AFE. In order to find that angle, you've got a couple of options here. Here's what you could do. You could recognize that AFB, so this guy right here, AFB, and AFE form a linear pair, right? Which I just gave you a definition right here. I told you a linear pair would show up. They form a linear pair, which means they have to sum to 180 degrees, and you could find AFE that way. Or maybe you recognize, right, I have two intersecting lines. In fact, let me draw my other line in there. Right there, intersecting lines, which means that these two angles up here and this angle down here are vertical angles. So if I take both of those guys together, they have to be the same as this guy based on vertical angles. Well, that's really simple, right? We already did that right here. 50 plus 90 was 140. Since they're vertical angles, this angle AFE must also be 140 degrees. So, two different ways to do this. You could have either done, hey, these are linear pair, set them equal to 180, solve for the one you don't know. Or hopefully what you recognized, hey, I got vertical angles here. If I add these two guys together, vertical angles tell me this has to have the exact same measure. And so what we get then is AFE has to be angle AFE is equal to 140 degrees, right? So now I've gone through, I've found all of them. These two were given to me. We found DFE by doing the angle addition postulate. I found angle AFB thanks to vertical angles, and I found angle AFE also thanks to vertical angles, but you also could have done the linear pair theorem. All right, let me go ahead and erase what I've got here. Hopefully you got all that written down, and we'll do our next example problem. I don't have to erase everything. I'll just erase the little bit that is over my problem. We'll go ahead and get rid of that stuff, and that way I have some space to work. And let's do our next one. Slide this up a little bit. Oh, and I apologize, there is a typo here in this guy. When I did my copy and paste and stuff for this diagram, I lost my right angle symbol. So that right there is a right angle. Should have that little box in there. So angle BFC and CFD, complementary angles. So here we go, here's what we're gonna do. I knew that angle also gives away what we're going to do. Angle BFC plus angle CFD equals 90 degrees. BFC and CFD have to sum to 90 degrees. Why? Well, that little symbol tells me that they are complementary angles. They sum to 90 degrees. They form a right angle. Well, I just plug and chug, right? That's going to be 6x right there. That's going to be 3x right there. I can solve for x with a little bit of simple algebra. So here we go. Let's plug and chug. 6x plus 3x equal to 90. Go ahead and combine like terms. That's going to get me 9x equal to 90 degrees. Divide both sides, right? Really easy, right? Divide both sides by 9. 90 divided by 9, of course, would be 10. So x is equal to 10 degrees. Now, I didn't ask you to find x, right? Please remember, I asked you to find the measure of those angles. So we gotta plug x back in. So let's do that. Let's plug x back in, which tells me that angle BFC is going to be equal to 6 times 10, which is going to be 60 degrees. So there we go. We found BFC. Let's keep going. Find CFD. Well, CFD is going to be 3 times x, which would be 3 times 10, which is going to be 30 degrees. And sure enough, just real quick looking at that, you know, right? 60 plus 30 is 90 degrees, right? And that's my right angle. Now, if you keep taking a look at this, here we go. So here's what I know. I know that BFC plus CFD form vertical angles, right, with AFE, right? So here's what I know. Since these guys sum to 90 degrees, vertical angles, AFE, also has to be 90 degrees. So we have, here we go, angle BFC plus angle CFD is congruent, right? I add those two guys together, add them together. It's congruent to the vertical angle, AFE. Angle AFE. Well, I know that these guys sum to 90 degrees, so 90 degrees is equal angle AFE. And we are on a roll. I got that one, I got that one, I got that one. Let's see what's left. Angle AFB. Oh, and please notice that angle AFB is a vertical angle with EFD, right? So here we go. These two guys form a linear pair, so that's really simple. We could simply do that. I know that angle AFE plus AFB have to sum to 180 degrees, right? They form a straight line. When I add them together, they're supplementary angles. They sum to 180 degrees. So take the two angles, add them together, set them equal to 180 degrees, but I already know AFE. Angle AFE is 90 degrees. So this is a really easy one. I know you guys can do this without a calculator. Right? You're going to go ahead and subtract 90 degrees to the other side, but piece of cake, 180 minus 90 is going to be 90. So angle AFB is also 90 degrees. Angle AFB is equal to 90 degrees. Sorry, I'm kind of writing stuff all over the place. I don't want to run out of space. Last angle, right? Last one, EFD, but we already talked about the fact it's a vertical angle, right? With the angle across from it, AFB. I know AFB, right? They have to be congruent. They have to be congruent. So, angle AFB is congruent. That's a terrible congruent sign. Hang on. With angle EFD, which means that angle, go ahead and substitute, there's 90 degrees, is equal to angle EFD. Alright, so once again, what we did is we used complementary angles, right? Two angles that sum to 90 degrees to go ahead and find the value of x. Once I knew x, I could find the value, the measure of BFC and CFD. We did it right there. Then I used the vertical angle theorem to find AFE, right? Vertical angle theorem, right? Where did I do it? Yeah, right here to find that angle, AFE. Then I use supplementary angles or the linear pair theorem, whichever one, the same thing, right? They form a linear pair, they're also supplementary, to go ahead and find the measure of AFB, which turned out to be 90 degrees, and then the vertical angle theorem again to get the angle across from it, EFD. So using both complementary, supplementary, and vertical angles, I was able to solve that diagram. All right, guys, hopefully that makes a lot of sense. Really important angle relationships, vertical angles, complementary angles, supplementary angles. We've gone through a couple of problems. I really had a good time taking a look at these with you. Thanks so much for joining me. I'll see you guys next time.